Okay, part 3, finishing up example 3, part C, show the non-permissible values on a graph. And you notice put the left side of the equation on one graph and the right side on another graph. So I've put the left side in y1. Okay, a little complicated with the brackets. Make sure you have brackets around the numerator and brackets around the denominator. And then, of course, it automatically throws brackets in on the trig function. So a lot of brackets on this one. If you don't throw brackets around the numerator and denominator, what happens is you're only dividing tan A by 1. So, and then with the other one, we have to go 1 over cotan, which is kind of weird, but you're going to go 1 divided by, and then we don't have a cotan button, so bracket 1 divided by tan x. Okay, set your windows 0 to 2 pi like they suggested, and make sure you're in radian mode still. Okay, we are, and let's hit graph. Oh, and did you guys change your second function to a bold line so that it plots over top? Actually, I'm going to go down here a second and so that you can see it plot. I'm just going to turn that off, I should say. Okay, so that's our original function. Of course, you can't see the holes in the graph, right? So I'm not really sure the point of this except to see the shape of the graph. Okay, so let's hit turn that one back on. Now you'll be able to see the bold plot on top of the other one. And there we go. Okay, so we need to kind of sketch this. They gave us a graph for negative 2 pi to 2 pi. Oh well, just go zoom trig and then it will look more like theirs. Zoom trig. Okay, go back to Windows. Negative pi, let's say 2 pi. All right, there we go. That's better. Okay, so now we have the same kind of grid that they have. Okay, so we have asymptotes happening at negative pi over 2, it looks like. So we'll put that here. So this is negative pi, and this is to pi. So we're changing the domain, negative pi to pi. Okay, and then we have another asymptote happening here. And then just bring up that calculator again. It looks like we have something like this here, and then like this. Does this look like any graph you guys know already? Yep, that's right. It looks like exactly like the tan graph, which kind of makes sense because 1 over cotan is tan. Okay, and then this one as well. Same idea. Drawing this one. Very sloppy. Hopefully yours looks better than mine. Okay, now we need to put holes in the graph. So let's use a different color for that. Okay, so we have holes for this one happening where 1 plus cos was 0. So it basically when cos was negative 1, which happened at pi and negative pi. So we'd have a hole in the graph here and here. Okay, we also had it where, because we had tan sine over cos, where cos was 0, and cos was 0. Oh, okay, well, we have asymptotes there. Those are more than holes in the graph. Okay, and then on the left-hand side, we had 1 over cotan. So where cotan was 0, or where x was 0, was again pi over 2, negative pi over 2. And cotan was cos over sine, so where sine was 0 was at these ones as well. Okay, there we go. Looks good. Now, last example, prove the identity. Secant squared over secant squared minus 1 equals cosecant squared. Okay, so let's do a left side over here, right side over here. Notice I'm not giving much room for right side, because which side are we starting on? Yes, the more difficult looking side, so that's the left side. Okay, so here we go. Secant squared over secant squared. Okay, you know what's screaming at me on these ones? I don't know if it is for you yet, but when you've done quite a few of these and you practice them lots, it'll be so obvious where to start. These, I know step 1 is simplify, but do you see all the squareds? You know, those are really kind of screaming at me. And one of the identities we have under squareds is, let's just write this off to the side, 1 plus tan squared x equals secant squared x. Okay, so I think we're going to be using that one, in particular in the denominator, because we want to make 2 terms into 1 term if we can. So if we subtract 1 both sides for that identity on your formula sheet, that would mean secant squared minus 1 is equal to tan squared. So we can replace that here. Don't replace the top. Changing 1 term into 2 terms usually doesn't help you. Okay, that makes it look more complicated. Okay, so secant squared minus 1 equals tan squared. Okay, now step 3, change things to sine and cos. I do believe that would be our next step. I'm just going to bring this up here. So secant squared, secant x is 1 over cos. So if it's squared, you just square both sides, and that would become 1 over cos squared x. Okay, all over top of tan squared, and again, same idea, tan is sine over cos, so to make it squared, just put little squares on those. That works if you're multiplying or dividing, does not work if you're adding or subtracting. Okay, so we are dividing by a fraction. How about we change that to multiply by the reciprocal? So 1 over cos squared, the numerator, times, flip the bottom, cos squared over sine squared. Okay, so we have cos squared on top here, which can cancel with cos squared on the bottom there, and we then have 1 over sine squared. Oh, that sounds familiar. What's 1 over sine squared equal to? That's right, cosecant squared, because cosecant is 1 over sine. So square them, and there we go. Yahoo! Thus it is proven, QED, left side equals right side. Question done. Okay, good job, you guys. Hopefully the assignment goes wonderfully for you tomorrow in class. Thanks for listening.